All right, so you've been digging into some really fascinating stuff about modern physics,
Yeah,
inflation theory, scientific consensus, and even like the limits of what we can even know about the universe.
it's pretty wild stuff.
Get ready for some serious aha moments, because today we're taking a deep dive into all of that.
I'm excited.
We'll be looking at an article featuring insights from physicist Leonard Susskind. Have you heard of him?
Oh, absolutely. Yeah, he's a giant in the field. Theoretical physics, string theory. He's done it all.
Yeah. So we're going to unpack the evidence for inflation theory, explore why consensus is so important in science,
Okay.
but also, why it can sometimes be maybe a little dangerous.
Right?
And we'll even tackle those mind-bending concepts like the multiverse and the Planck scale. You ready to jump in?
Absolutely. Let's do it.
Okay, so first up, inflation theory. Like really quick recap.
Okay.
It's this idea that right after the Big Bang, the universe expanded super, super fast, like way faster than the speed of light.
Right. And it's not just a cool idea, right? Like,
Right.
there's actual evidence to back it up, which is what Susskind is really emphasizing.
Yeah, and the evidence is like actually pretty convincing.
Oh, for sure.
Two things that stood out to me were the fluctuations in the cosmic microwave background radiation,
Right.
which is like the universe's baby picture,
Exactly.
and the patterns we see there actually like match up really well with what inflation predicts.
Yeah, it's like a fingerprint.
Yeah. And then the way galaxies and clusters are spread out, like the large-scale structure of the universe, it also lines up with the idea of inflation.
Right. And what's fascinating here is that while this evidence is like super strong, Susskind actually acknowledges that it could still be wrong,
Hmm.
which really emphasizes a crucial point about science. It's always open to revision, always open to change based on new evidence.
So it's all long as like set in stone.
Exactly. Even when things look pretty solid, you got to stay open to new possibilities.
Okay, so is it all about just following the crowd in science?
Hmm.
What about those like rebellious geniuses who break the mold?
That's the big question, right? Like, how do those groundbreaking ideas emerge when you have this whole establishment saying, no, this is the way it is?
Yeah.
And Susskind has some interesting thoughts on that.
Yeah.
He argues that consensus is actually generally a pretty good indicator of truth in science, right? It's like you have all these experts who have been looking at the data, debating the theories, and they've kind of arrived at a shared understanding.
Yeah, like the combined knowledge.
Exactly. But he also warns about becoming too reliant on consensus.
Right.
Too much reliance on it can stifle those truly groundbreaking ideas that, might initially seem a little crazy.
Yeah, imagine if everyone had dismissed Einstein, right?
Exactly. When he first came up with relativity, people thought it was nuts, but it revolutionized our understanding of the universe.
Or quantum mechanics.
Oh, yeah, totally. Like, those were radical ideas that went against the grain but ended up transforming physics.
So how do we balance the need for a solid foundation in science, that consensus, with the openness to challenge those existing ideas?
Right. It's a tough one, right? It's almost like, how do you walk that tightrope between respecting what's come before and being open to something completely new?
Yeah.
And there's no easy answer, but I think for me, a healthy dose of skepticism is crucial. You have to be willing to question those assumptions, even the ones that seem like they're set in stone.
Okay, so let's get into the really trippy stuff.
All right, yeah.
The multiverse, string theory, all those ideas that seem almost impossible to prove.
Right. These are the ones that really stretch the imagination.
But I mean, Susskind makes a point that just because we can't verify a theory now with our current technology and understanding
Yeah.
doesn't mean we'll never be able to, right?
Exactly.
Like, think about atomic theory. It was once considered completely unverifiable.
Right. You couldn't see atoms.
Yeah. It took, like, forever for technology to catch up and finally confirm that they existed.
It just goes to show you that what seems impossible at one point can become reality with new discoveries and advancements.
So are there, like, specific things we could look for, like evidence of the multiverse or string theory?
Yeah, I mean, it's tough because these are theories that deal with, the fabric of reality itself, but there are some potential avenues.
Okay.
For the multiverse, you might look for subtle distortions in space-time, like almost like ripples in a pond if another universe brushed up against ours.
Oh, wow.
Or you might look for echoes in the cosmic microwave background radiation, kind of like leftover signals from the very early universe.
Huh.
For string theory, the focus would be on finding evidence of those tiny vibrating strings that they believe make up everything.
So like direct evidence of those
Right,
strengths.
and that might involve looking for specific patterns in particle collisions or, again, in the cosmic microwave background radiation.
Okay, so the universe might be holding on to secrets that we just haven't figured out how to unlock yet.
Exactly. The universe is full of mysteries.
Is there anything we like definitively can't know? Are there like hard limits to our understanding of the universe?
Well, that brings us to something called the Planck scale, which is kind of mind-blowing. It's the smallest possible distance that we could theoretically measure.
Like the absolute
Yes,
smallest?
the smallest unit of space.
Wow.
The problem is, to probe the Planck scale, we would need to concentrate so much energy into such a tiny space that we would create a black hole.
Wait, a black hole?
Yeah, it's kind of a paradox. Like,
Yeah.
the very act of trying to see what's at that scale would actually prevent us from seeing anything.
So it's like we hit a wall.
In a way, yeah. It suggests that there might be fundamental limits to what we can directly observe.
So our quest for knowledge about the universe could be limited by the very laws of physics themselves.
It's a humbling thought, but it also makes the pursuit of knowledge even more exciting, in my opinion. Like, we're trying to push the boundaries of what's knowable.
This deep dive has really stretched my brain, in a good way. If there are limits to what we can observe, do we need to rely more on things like mathematical models or conceptual frameworks to understand the universe?
I think so. We might need to get more creative in how we explore the universe.
Definitely some food for thought. Thanks for joining me on this deep dive. I know I learned a lot today, and I hope you did too.
It's been a pleasure. Always fascinating to explore these big questions.
Absolutely.